So looking at number 30 in 6.5. Okay, we're going from 0 to 2. This, I moved it to the numerator, so it should be a negative 4/3. There we go. When does this have an issue in the denominator? When what's true? When x is 1. Okay, so what you have to do is you have to split this up at 1. Okay, so you're going to go from 0 to 1. And then you're going to go from 1 to 2. And that should cover everything, right? Okay, so then that just goes in here. And then it goes in here. Now, can I actually take it at that 1 value? No, I have to replace this 1 with a letter. So what letter you want to replace this one with? Okay, so the limit is b approaches 1. And if I'm going from 0 to 1 on a number line, am I approaching it from the left or the right? From the left, so I put a little minus sign here. And then instead of going from 0 to 1, I go from 0 to b. Okay, so any questions on that part of it? And I just have this x minus 1 to the negative 4/3. And then I have to replace this 1, so typically our book chooses what? A. And if I'm going from 1 to 2, which side am I approaching it from? The right. So if it's at the bottom, it should be a little plus there. And then instead of 1 to 2, I'm going from A to 2. Oops, I missed my dx here. Okay, so any questions on that? Does that look okay to everybody? You know how to solve each of these separately, right? You just solve them separately now. So I'm just going to go ahead and I'm just going to solve this side here first, and then I'll worry about the other side. Like you can do them both at the same time, but you can just go like this. You know, I'm just going to do this part first. So I've got the limit as b approaches 1 from the left. How do I take antiderivative of something like this? Add 1 up to the exponent. So if I add 3/3, I get x minus 1 to the negative 1/3. And then what do I have to do? Nope. You divide by the new exponent, right? Or multiply by negative 3. Because if you're dividing by negative 1/3, that's the same as multiplying by negative 3. And do I have to worry about the 1 over m? No, because my m's 1 here. Okay. And then I'm taking this from 0 to b, right? Being this is a negative 1/3, let's write it as negative 3 over x minus 1 to the positive 1/3. I think it'll be a little bit easier to plug these into there. So if I plug b into here, I have to keep that limit until I take it, so I'll write it down again. If I plug in b, I just get b minus 1 to the 3rd here, right? So negative 3 over that. And then I subtract and I plug in 0. So if I plug in 0, I have negative 3 over 1, right? Because if I plug in 0, I get negative 1, and negative 1 to the 3rd is negative 1. Because it's an odd exponent, right? So it'd stay negative. If you need to try it in your calculator, you could. Okay. You don't trust my... Huh? Yeah, it's 3 negatives, so it'll be a negative. Because these two like cancel each other, right? So you're subtracting 3 back here. Yep. Now we're approaching... B is approaching 1 from the left. So if I'm approaching 1 from the left, and this is, you know, the hardest part for some of us here, this is going to be just a little bit smaller than 1, right? So like 0.99999. And if I subtract 1 from it, it's slightly negative, but it's really, really close to 0. So what I have is I have negative 3 over a really, really, really small negative, right? So the 2 negatives is going to make that a positive, and 3 over something infinitely small is going to be infinitely big, so it's going to be positive infinity. So this turns into infinity minus 3, which is still infinity. Do I even need to do this part of it? No, because what do I know if this goes to infinity? The limit doesn't exist, right? So that means that this is divergent, right? So we just can say it diverges. Yeah, but it doesn't cancel out the infinity. If either of them go to infinity or negative infinity, it's just done. You don't have to do it. It would not be 0, no. Because one infinity could be larger than the other. I know it sounds silly, but okay. So I would say here limit does not exist, just to clarify that. So questions on that? Does that make sense now? The getting the setup was a little bit different than the other ones because you have to split it at that spot. So the other one was what, 32? Is that right? Yeah. Okay. So 32, we're going from 3 to 5. Okay, where is this going to have an issue? At 0 and at 3 and at negative 3. Okay, where's the only spot that we really care about from 3 to 5? Just 3, right? So we're going to have to replace this 3, and typically we replace it with A. So pick a letter, it doesn't matter. So it says A approaches 3 from which side if we're going from 3 to 5? The right, okay? Think about 3 to 5 here. 3 is here, 5 is here, so I'm going to be approaching 3 from the right. Does that make sense? Okay. And then we're going from A up to 5. So any questions on that first step there? Now it's going to be interesting to try to come up with our integral of that. So it doesn't look like one of our common ones. Yeah. It might be one where we have to try a few things and see what happens. I'm just going to focus on the integral. I'm not going to write all the limit stuff. So this is just some scratch work. Because one thing we do when we see that square root, guys, one thing we do when we see that square root is try what? Use substitution. Let's try it and see what happens. I have a feeling it's not going to work, but it might. Yeah, we've got this other stuff here, but what other ideas do you have? Do you have a different idea? The only thing with the partial is we can't get them all linear, you know, because we have that square root piece there. So let's just try use substitution. Sometimes it surprises you and stuff falls into place. We'll see what happens here. So if I take the derivative, that's 2x dx. So my dx is du over 2x. So this is 1 over x squared and then square root of u. And then this is du over 2x. And that just gives me an x cubed in the denominator, right? Which actually is making it worse.
Thanks, Adam. More worstest.
The worstest. Okay. So we have x cubed square root of u. See, the thing is, if you had an x squared, we could replace it with like a u plus 9, but we can't really do anything with that here. No, we'll get it. We'll get it without him. Let me think here. I don't think we can do that. Okay, what are the other ways we know to integrate? So we got u substitution. Integration by parts seems like it would be not optimal. No, we don't skip them.
We never do it.
Now I'll have to think about this one for a minute.
Here, we'll help. Oh, I know the answer.
You know it? 32. Let me think here. So I don't think we can do like a partial fractions like we would want to. Okay, duh. So if you guys get your packets out or that table, we're going to look at rule, what did we agree on? 28. So if you look at rule 28, page 441. Okay, so if I have the integral of 1 over x squared, square root of, guys, x squared minus 9. What is my u equal to? X, right? Just x, because it's u squared and x squared here. And my a is 3. And some of you did this wrong on your quiz here. So am I going to use the plus or am I going to use the minus for what's here? Wasn't this x squared minus 9? So I'm always using the bottom piece. Do you see how in the rule it says u squared plus or minus a squared? So you're using the bottom piece of all of those. Okay, so you're using the minus there. So when I do the first piece there of what it equals, do I use the minus or the plus?
Oh, plus.
I use the plus because it's on the bottom. Do you see that? So let me just write out the rule so I can point to it here.
Oh, I never. So if it was plus, so you'd use the minus first.
Yeah. So this is u squared, and then underneath here it's u squared plus or minus a squared du. And it equals minus or plus the square root of u squared plus or minus a squared over a squared u plus c. Okay, so this is what I'm talking about here, and this is what some of you did wrong. So do you see how it's a minus in this rule here? So we're using the minus, which is the bottom half. So we're going to use the bottom half. So we would use this plus here, and we would use this minus here when we write our rule. What? That's with any of them that have like the plus or minus thing, okay? So when I'm writing this, instead of, I'm going to use the plus here, right? And instead of the square root of u squared, I'm going to put the square root of x squared. And then instead of plus or minus, I'm choosing the minus. And then a squared is 9. And then it's over a squared u, which will turn into 9x. And then I have my plus c, but do I need my plus c for this problem? No, because I'm going to be using this stuff up here, right? So I've got this right here, which turns into limit as a goes to 3 from the right. And I've already taken the integral, which turns into this. So I've got the square root of x squared minus 9 over 9x. And I'm taking that from a to 5, is that right? So questions on that now? Okay, so we'll continue with that. So then I plug in what first? 5. So let's go ahead and plug in the 5. I haven't taken the limit yet, so you just leave it out front. So if I plug in the 5, I get 25 minus 9, which is 16. Square root of 16 is 4. So this turns into 4 over 45. And then subtract and you plug a in. And if you plug a in, you get a squared minus 9 over 9a. Any questions on that? And then remember, we're approaching 3 from the right, so it's a number that's just slightly larger than 3. So under the square root, is it going to be plus or minus, positive or negative? Positive, but it's really, 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 really close to 0 over about 27, right? So 0 over about 27 is 0. So really what I have is 4 45ths and then minus 0. So I would say that this one is convergent, and that's what it converges to. Yep, and that's the right answer. So cool. We did it. Yeah, don't forget that you have that table. Obviously on your test you'll have it right with you, so you won't really forget, but